All right, what's happening? It's day 12, advent of code. We are getting there. We're getting there. And after this, we're going to be almost halfway. So, super excited. Thank you for watching this. Subscribe, like, whatever it is. Let me know what you think. How is your advent of coding going? I've got our day 12 template. I made a few changes to my utility script. Specifically, I finally decided to add the small version. Like, we've been doing this enough times now. I'm just like, let's just generate the small input and the big input automatically. You see that here. And I'm just going to have these two be separate lines, instead of trying to change the file name manually every time. That was starting to get a little bit repetitive, and so I coded it out. All right, so not much else to say there. Let's get underway. We'll hit that start button. We'll go to day 12. Why is day 13 up there? I have no idea. Your ferry made decent progress. Storm. Unfortunately, bad navigation computer produced extremely circuitous instructions. Use the PA system to ask if anyone can help you volunteer. The navigation instructions consist of a sequence of single character actions paired with integer values. After staring at them, you figure out they probably mean north, south, east, west, left, by a number of degrees. Wait, why would you need any of this if you have those? All right, well, let's move on. It starts by facing east. Okay, so it's facing east. Only L and R change the direction the ship is facing. If the ship is facing east and the next direction is north, the ship would move north 10 units, but would still move east if the following action were forward. Okay, so the ship is just going to go sideways 10 units. So I guess left and right is really only useful in relation to forward. Face 10 would move 10 units east because the ship starts by facing east. Okay, this starts by, I gotta make a note of this. This is an important note. I still have my notes from the last problem. Okay, ship starts by facing east. That's important. N3 would move the ship 3 units north. I think I'm gonna start sketching this because I just realized I didn't change this to the desktop. My apologies. Wow, I just said all of that while not showing you any of it. I was saying that in PyCharm, I've got the these utilities going. Yep, and here's the problem. Go back up to show you all that stuff. But again, you can go to the day 12 code description to see for yourself. Okay, so let's do this. Starts out facing east. I still have my sketches from day 10 part 2. That was a nightmare. Facing east. I'm going to just draw an arrow that faces east. And then it goes to the east 10. Why does it say north 0? East 10. Okay, so I guess we can assume kind of the starting point is we're on a, oh wow, I just drew east facing to the left. East is to the right team. All right, so it goes east 10 units. And so it's like at coordinate, like on a coordinate axis of east, west, and north, south. That's like the location is east 10, north 0. We're probably going to translate to X and Y at some point. North 3 would move the ship 3 units north to north 3. East 10, yep. Forward 7 would move the ship another 7 units east because the ship is still facing east to east 17, yep. R 90 would cause it to turn 90 degrees and face south. It remains there. So we'd say turn 90. And then F11 would move the ship 11 units to the south. So 411, so we're at -8, aka south 8. The ship's Manhattan distance, the sum of the absolute values of the east-west position and north-south position from its starting value is that. What is the I'm hoping that all of the stuff that follows L or R are multiples of 90. Let's find out. L, oh, this is a long file and there are a lot of L's. But it looks like that is the direction that this is headed. And there's always a number, always a single letter that comes after that number, before the number. So we slice off the first element and grab the int from the second, and that can be our pair input. So our parse line should do line at 0 and line everything after that, convert that to an int, wrap that in a whatchamacallit tuple, and return it. And so that should give us lines, and it's empty because I haven't actually supplied any form of input. Good job. So there's this one, and here's our super tiny example, to which I think we're gonna probably want to extend this example. Whoa, I just clicked get. Here we go. Nice. So now we're gonna process each of these. I'm going to take a minute here to think. The mapping of north, south, north, wow, I can't say the words, north, south, east, west. So we need kind of like ship orientation. And then north, south is kind of positive, negative, y. East, west, east is positive x on this notation, right? Yeah. And I need some way to think about which way the ship is facing. All right, so we need some logic for that. I'm thinking some modulo math. The only thing I'm potentially concerned about is how does that work when you go negative. So like negative 180 modulo 360 is 180. Brilliant. And like negative 90 mod 360 is 270. Yeah, I can live with that. So we can take whatever they tell us, and L is negative, so L is subtract angle, R is add angle, and then you take, you know, position, angular position mod 360, and then whatever you get, I think we're calling this way 0. So 0 is east, 90 is north. Ooh, L is subtract angle? No, L is add angle. Have to like remember our polar coordinates, folks. 180 is west, 270 is south. Great. So that's how that plays out. Cool. Let's parse it up. Dun, dun, dun. For action in lines, we're going to basically, you know, position and orientation. Position equals 0, 0. I don't know why I put so many spaces there. Orientation equals 0 degrees. We start out facing east. And we're going to say for each one, so it's like forward 10, or, you know, north 3, we say if whatever the number is, we want to move the coordinate in a certain direction. So what I'm thinking is this is like a action map, let's call it. And so like when it says north, what I want is for it to return. So north increases our y-axis, our y value, right? And yeah, so that's like north is, actually I'm just gonna write it in here. North is 1, 0, right? It increases our, y value, increases our y value. Like we saw here, it increases north. And then, so then south naturally will decrease our y value. So what I'm gonna do is then multiply this, because of the 0, it doesn't matter, I can multiply it by the number and then add it to the position, and that'll be the amount that it changes by. East is positive. So really borrowing from kind of some of the ideas from yesterday here. Negative. And then when we, yeah. So we can say something like that. And then for this, we need to change position. So let's say if action in action map, then we can do action map. And the reason I'm not using get is because I want to do something different if it's in the LRF space. Action map at action times, not action. So it's for direction and distance. So direction times distance, that's the change. And I want to element wise add, I'll just say combine or position and change. I know you can add it element wise, I just can't remember how to do it, and someday I'll look it up. That's what I'll say for now. Combine A, B, we did this yesterday, let me just grab it. Yeah, good. And I think I do want it to be a list this time, just to be consistent with this whole shebang. I know it doesn't have to be. Yeah. We can, all right, we can do something here. We can, I don't want to change it in place though. That's, ugh. Okay, so we'll do that. And position, combine the position, return position. I just want to test this out. Oh, not return position. No, position, okay. And so action is not defined. You don't say. Where did I accidentally write action? Oh, if action, yeah. If direction in the action map, good. So we end up at 0, 1. Really? Do we now? What are the inputs? The other inputs? We go north, we go right, which should be, okay, let's take a look at what we're doing here. So when we get to, that's not helpful at all. When we get to here, north, 3, north. Oh, multiply by distance does not do the thing I think the thing that I think it does it? Bet you it doesn't. Yeah, okay. That's fun. Let's do it this way then. Instead of having it this way, we're gonna have a C here. This is getting ugly. What we want this to do is A plus B times C, all element wise. And so we're gonna do B times C, B times C, and we're gonna pass in distance here and direction. Sure, call it change, that's fine. All right, now we're getting somewhere. So let's, okay, we'll add more examples for computing this later. For now, I want to figure out the forward back problem. If, all right, so with forward back, this is angle map. Yeah, I should have called the other one direction map. Left is positive and R is negative. So that is pretty minimal there. And F is just something else. If direction in angle map, then we do angle map at direction times, so that's that number, times the distance, which in this case is the angle, and we're going to add it to orientation, and we're going to mod the whole thing by 360 and save it back to orientation, right? Good. So we're gonna once again, I'm gonna move the print statement up this time. Int and list. Which one is, oh, it auto completed, funny. What is it called? Angle map at direction? Yeah. So let's print out our orientation at the end here. And I forget what it was supposed to be. Our turnaround and face south. That is 270, so that's good. Granted, we only made one turn. This is hardly what I would call a robust example. Now we have to figure out this forward nonsense. If direction equals forward, then we just want to move in the direction based on the angle. Let's do this mapping then. This is angle to direction 0. It's this, isn't it? Or is it? Is this thing? Copy that. We'll replace the equal signs shortly. So this is what we're looking for. Okay, great. So I just need to get these coordinates so I can map it to these numbers basically. And then it's just like moving them. Yeah, so it's the same as this stuff. You know, to the point where I want to do this. If F is in direction map, and at the end we'll say direction equals angle direction at the whatever orientation they're in, that gives us a letter. So we change the letter to this other letter, and the distance is the same. So it'll work? Maybe? Yeah! That is a cheap way to do it. Love it. And so let's try the whole shebang, not having tested anything, but you know, hey, maybe it'll work. So we want the sum of positions. So position at 0 plus position at 1, ABS, ABS, return. Cool. Yes. All right. Now, before you can give the destination to the captain, you realize that the whole action meanings were printed on the back of the instructions the whole time. Almost all the actions indicate how to move to a waypoint relative to the position. What? Action N means to move the waypoint north. Oh, we're moving a waypoint. Rotate the waypoint around the ship left. Rotate the waypoint around the ship. Counterclockwise the number of days, right? Move forward to the waypoint a number of times equal to the given value. Oh, snap. So it's like we're moving the waypoint around, and then the only time we actually move the ship is towards the waypoint. Interesting. I have to think about how to implement that last thing. It's like I'm thinking like subtract the coordinates because you gotta find the direction of moving in, right? If the ship moves, the waypoint moves with it. Oh, crikey. Okay. F10 moves the ship to the waypoint 10 times. A total of 100 units east and 10 units north. But where is the waypoint at the beginning? Oh, whew. 10 units east and 1 unit north relative to the ship. So the ship, 10 units east and 1 unit north. And then here's W, the waypoint. Leaving the ship, moves the ship to the waypoint 10 times. A total of 100 units east and 10 units north. Huh. Sorry, I dropped the pen. Oh. So every time the ship moves to the waypoint, it moves it the whole way, not one unit. So it's like 10 times the waypoint path, like distance, path, whatever. Or I guess you could say 10 times the, Manhattan walking. North 3 moves the waypoint 3 units north. So we keep track of the waypoint's relative position, moving it around a similar way as before, except F has a different rule now. And that is fine. Like before, we were keeping track of the ship relative to its origin. Now the ship is the origin and the waypoint is relative to it. F7 moves the ship 7 times. So like we only move the ship in calculation based on the position of the waypoint. Oh, okay. Okay, this isn't bad. The ship's Manhattan distance from its starting position is yada. Okay. So we only care about the waypoint relative to the ship anyway. But we do need to keep track of the ship's position relative to the origin still, so that we can do this final step. Interesting. Okay. I'll take this whole thing for part 2 with me here. Let's cancel out part 1 and paste that in. Switch this back to the small input. So now we have to keep track of waypoint position and waypoint. Oh, let's properly refactor this. Refactor. Good. Man, I love this intelligent renaming. Rename, refactor, rename. Oh, renaming is not finished yet. Okay. Refactor, rename, way orientation. And then we just need one final thing, which is ship position. Wow, okay. The action map stays the same, the angle map stays the same, the angle directions also stay the same. So for each thing we see, this is definitely going to change, so I'm just going to blow that away right away. We are keeping track of the relative way orientation and let's see, the ship moves, the waypoint. So F10, N3 moves the waypoint 3 units. Oh, but it starts, the waypoint starts at 10 east, 1 north. So way position starts at 10 east, 1 north. Ship is still at 0, 0. We'll go back to this sort of a return value. And position not defined, because we're calling it way position. Orientation not defined. Yes, yes. Thank you. And what do we got? 10-4, 270. Rotate to 4 units east, 10 units south. 10 units east, 4 units south. Okay, I got something mixed up in here. Moves the waypoint 3 units north to 10 units east and 4 units south. Let's check. I want to check something here. North-south is the XY. So when it says the waypoint is XY, this should be 4, negative 10. Moves the ship to the waypoint 7 times. The waypoint stays at 10 east, 4 north. That's 10, 4. Oh, that's where I'm at here, 10, 4. So we don't care about the forwards. So really it should only be north 3 and then R 270. R90 rotates the waypoint around the ship 90 degrees. Oh, the rotation is a little bit more nuanced. Yes, it's not just rotating it in place, it's rotating it around the ship, moving it to, so originally it was at 10, 4. Then R90 takes it from 10, 4 to being 4, negative 10. 90 degrees. Why is it negative 10? Oh, R90. Yes, yes, yes. R90. So it's minus 90. So who remembers their angular polar? Man, someone's going to do this in polar coordinates. But basically, on a graph, the 90-degree turn points end up looking something like that. And so it's like if you have some x, y, you know, in our case it was 10, 4, right? Let's just put 10, 4 in our example. And then minus 90, right, R90 in this case, put us at 4, negative 10. Like, it's all just like swapping and negating the various values. Positive 90 then would be the negative 4, positive 10. And 180 switches both. But switches both signs without switching their places. right? It's negative 10, negative 4, negative 4, positive 10, positive 4, negative 10, positive 10, positive 4. So this means that when we figure out the direction that it's facing, right, that it's rotating to, is this still the right mapping to take it on? Like, let's say 90 is north, right? And so when we go north, it's 0, 1. Is 0, 1 useful in making this conversion for us? Because mostly what I'm seeing is if we're able to figure out the rules around, like, when you add a 90, you always do blah, right? Like when you add 90 here, it looks like you always swap x and y and negate x. Swap x, y, negate x. Now, is that true when I go from 90 to 180? Swap x and y, negate x. Yep. Swap x and y swaps, negate x. Yep. Swap x and y, yeah. So that's positive 90. Every 90-degree turn, we do that. And a 180 turn, you just do it twice. So should we be dividing by 90? Well, at least the change. And then when we go the other way, it's also swap x and y, but negate y. Swap x, y, negate y, right? Swap x and y, and then we negate y. Yeah. So it's just a matter of which one gets negated. So in that case, it's always something's gonna get negated. So this angle map isn't quite right for our part 2 purposes. So what we should do is we can get direction and distance. And so we take distance and we mod 90. And yeah. And we can say direction, right? If direction is actually it doesn't matter. We always swap x and y. It's more a question of do we negate y or do we negate x? Okay, so if direction in angle map negate x, negate y. So let's change angle map then. We're only using angle map here. If it's L, if we're going to the left, that's negate x. So it's -1 and +1. And then the other one we're negating y. So that looks something like that. So we can grab the value in angle map at direction. So this will be the multiplier. Negate either x or y. But first we need to take the distance and mod 90 on it to figure out, divide by 90 to figure out how many times to swap x and y. And each time we need to negate x. Okay, so chunks equals that, or I guess for I in range of this, right? So it's like if it's 90, it's range 1, it's gonna go 0. Okay, that'll work. So then each time we do it, we'll swap direction, which is I don't know why I didn't break this out sooner. Oh, direction is not what I think it is. Okay, swap position, way position needs to get swapped. Where is that? I can write that manually pretty easily. Way position 0. Way position 1. Do I want to do it this way? This should work. Let's just confirm that real quick. A is 1, 4. A at 1, A at 0. A gets that. Oh, I did it backwards. A at 1 is A at 0. Swap. 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 Great. So did I write it the same way here? Way orientation at 1, way orientation at 0. Make that a list. That's a swap. So for each time we do it, we swap, and then we negate the two things. And I guess we can pass in, we can do combine and pass in a 1 for C. Combine way position with way position with the angle map direction. And maybe we can just have combine take a default 1. There we go. Now I don't have to type that in, make it confusing. And this returns a new way position. Way orientation kind of doesn't matter. Like, it's just going to happen. So that doesn't matter anymore. Yeah, they're all kind of commented out here. Interesting. Cool. And so this will theoretically get our way positions rotated around, hopefully the correct number of times. Way position, which we returned, but isn't being printed, so something went wrong here. Oh, combine. Float cannot be interpreted as integer. Really? That's interesting that it did that. Int is not subscriptable. Yes, that is a true statement. It's not way orientation, it's way position. 5-9. That doesn't sound right. Oh, but that's because we did the whole, we didn't move forward, right? Sort of. Kind of. It's relative, right? So I'm not quite getting it right. Why is it off at 1? Like, it should still be 4s and 10s. Are we not multiplying? For negate, yada yada yada. Oh, we are adding, not multiplying. Yeah, we want to be multiplying. Yes. So this combines in a slightly different way than that combines. All right. Dot A comma B, A at 0 times B at 0 plus, it's not really dot multiply, it's element wise multiply. Mult A at 1 times B at 1, turn that list. So way position, right, is something like 10, 4, And then we take way position and we multiply by the angle map to do like 10, 4, going to, 4, -10 or something like that. So yeah, 4, -10. Yep, that's what we're expecting. Good, good, good. So now comes the final step here, hopefully, where we're going to move the ship forward each time, right? This step here. If it is forward, come on. I don't even know what the keyboard shortcut is to collect the code. I just do it by accident sometimes. We're going to move the ship to the way direction by the number of units supplied. So whatever the way position is, we don't care about the way orientation, and apparently never have. And we're going to modify the ship position by the way position times the distance. So that sounds a lot like, to me, like a little combine function. I really am not loving the autocomplete overwrites here. Okay, so it's ship position times way position multiplied by distance, and that's the new ship position. And again, the overwrites killing me. So let's return ship position and 214 and 72. Ah, nice, nice. All right, good. Let's just print that and do that. We don't want way position, we want ship position. And finally, we need to switch the input. And there's our answer. Whew. Ship traveled a long ways. Yes. Clean take. That was a clean run through. I'm pretty happy with that. Really getting into the groove of these problems, I guess, or something. Or just got an easy problem for the weekend. Anyhow, let me know what you think in the comments below, or on Twitter, and we'll catch you tomorrow for day 13, lucky number 13. Let's call this day 12. Rotate the waypoints. All right. We will catch you later. See ya.